the following exercises, solve the equations over the complex numbers. Okay, so we're bringing back complex numbers. We already have a playlist of complex numbers and all the questions that we have done with them. And if you want to go back to the playlist, the link is in the description below to check out all of those videos. But remember that complex numbers are non-real. They're non-real numbers. They are not real. They are imaginary. And if they are imaginary values, they have to deal with the letter I. I for imaginary. And remember that the I just stands for the square root of -1, right? Because technically, if we have a negative under the square root, like if we were trying to solve for the square root of -25 and you put that into the calculator would say, no, there's no real values for this. That means that they are non-real. It has to deal with imaginary numbers, complex numbers. So that's how we get rid of a negative in the square root, by just denoting that it's with I. Okay, so let's see if that's the issue. It definitely has to be, because they say that these are already complex numbers. Now, this is a quadratic, right? And a quadratic either looks like this or it looks like this, right, on a graph. It's like a frowny face or a smiley face. And, oh boy. Sorry about that, guys. And basically what we're solving for is we're solving for the roots. In this case, we're solving for the complex numbers, because whenever your quadratic is equal to 0, when the y value is equal to 0, you're just finding those roots out. Now, with quadratics, there is always going to be 2 points. Well, hopefully, there's going to be 2 points in which it crosses the x-axis. Those are your roots. You're solving for what x would be equal to here at this intersection and what x would be equal to here in this intersection. And if you notice that there's a negative value as well as a positive one, right? So in hopes that, these examples will show us that we'll get 2 answers, one with the positive and one with the negative. So let's see, we just have to solve for x. Okay, so this one's not going to get us, right? If I just rewrite this, it has x squared plus 36 equals 0. So the first thing is rule of algebra. I want to get the x by itself. So I'm going to subtract 36 on both sides. And I get x squared equals -36. Now, it's being squared, so the opposite of squaring is taking the square root. And I have to be fair, I have to take the square root on the other side, and look, here's the issue. I have a -36 under a square root, right? So that's where the imaginary numbers are going to come from. Now just know that when you manually, or when you actually draw a square root, just like we did, you get 2 answers. When this cancels, because they are opposites, the x value that you will get is going to be the positive and the negative answer. So we will always say plus or minus. You will always say that if you manually draw the square root, just like we did, right? We had to manually draw the square root. However, if your equation just says something like this, and the square root is already in the equation and you didn't draw it, you will only give the positive number. But that's another story for another day. In here, though, since we manually draw the square roots, we get both answers. Okay, so now we have something like this, right? The square root of -36. How do we get rid, or not get rid of, but how do we separate this negative by 36? Well, I can say that the square root of -36 is the same thing as saying the square root of -1 times 36, right? And this would all be the same. And that way I have 2 different square roots. I have the -1 component and the 36. So I can break this down even further. I can say that x is equal to plus or minus the square root of -1 times the square root of 36. When you have 2 numbers, being multiplied each other under the same square root, you can separate the square roots. And now we know from our complex number playlist that the square root of -1 is just an I value. And we know that the square root of 36 is a 6. So this would technically be I times 6 plus or minus, right, equals x. And with complex numbers, the number goes in front. So it would be plus or minus 6i. So that means that the x value could be either a 6i or it could be a -6i. And there are your roots. On our imaginary coordinates, our parabola will intersect the x-axis on x equals 6i and x equals -6i. Let's do the next one. So the same exact idea. The first thing I'm going to do is I want to get x by itself, right? So x squared plus 27 equals 0. I will subtract the 27 from both sides, and this will cancel, right? So I'm left with x squared equals -27. So let's take that square root. I manually drew that square root in. The square root will cancel with the square, and my answer will have 2 values. It will still be the square root of -27. So we have this issue here where we have a negative times a 27. So let's first separate the negative from the 27, right? So x would equal plus or minus the square root of -1 times 27, right? And when you can do that, you can separate it into its own separate radicals. And you don't have to draw out all the steps. I'm just showing you them, but when you start getting good with math, you can kind of jump steps, We know what the square root of -1 is, right? So that's not the issue. That's the I, and this would be still plus or minus, and that's what x equals. And now what's the square root of 27? It's not a perfect number, so I can't just break it down. But maybe the square root of 27 can be simplified into 2 different radicals, that maybe one of the numbers is a perfect number. Let's see, is there any perfect numbers multiplied by another number to get 27? Yeah, right? If I take the square root of 9 times the square root of 3, 9 times 3 is 27. And what is the square root of 9? The square root of 9 is 3. And this, we can't really do much with it, right? You can't really break down the square root of 3, so that just follows along for the ride. So the square root of 27 is the same thing as 3 rad 3. And that's being multiplied together. So my answer would be plus or minus I times 3 rad 3 or 3 rad 3i. But remember, plus or minus, so you have 2 answers. X will equal 3 rad 3i, and it will equal -3 rad 3i. Those are your 2 roots in which the graph will pass the x-axis on our imaginary plane, our complex plane. And that's it, guys. There you go. What do you think? Let me know in the comments if this helped you. Give the video a thumbs up, and if you want to subscribe to the channel, that would be awesome. I greatly thank you, and you guys rock. I mean, you guys have been great. Let's keep going, all right? More math on the way. See you in the next lesson. Bye-bye.